3.4, now that I've verified that my microphone is actually on. So this is instance fields. Okay, which are like variables except they're a permanent part of an object. They're data stored in an object for the life of that object until that object dies. Okay, so back to our bank account. An object uses instance fields to store its state, that is, data it needs to execute its methods. A field is a technical term for a storage location in a block of memory, and an instance of a class is an object. So we don't want anybody else to touch it. This object should only be the only thing, its method is the only thing that can actually access its instance field. So we're going to make it private. So access specifier type name. And again, we want these write these at the beginning of our class. Now, if you look on page 94, if I were to have Harry's checking and Mom's savings, they're both bank account objects of the bank account class. So they both would get a balance. However, a balance instance field, but theirs is unique. Each one has its own unique instance field called balance, and it is the only thing that can touch it. So an instance field declaration consists of an access specifier. They are going to be private for our intents and purposes for now. The type and the name. Okay, private means that the instance field can only be accessed by the methods of the same class, no other method. Okay, so I can do the balance can be accessed by the deposit method of my bank account, but not, for instance, the main account of something else. This process of hiding the data and providing methods for data access is called encapsulation. We will make instance fields private in this book. I'm just reading off of it, and also for our class, just to be safer. So, 3.5. Constructors and methods. Constructors contain instructions to initialize the instance fields of an object, so they have to take care of them. It could be a default constructor with no parameters that just sets everything to 0, or it could be a more specific constructor like and we'll overload it. So the second constructor, the bank account class, allows you to have an initial balance amount set. The default one just sets it to 0. So a constructor has a simple job to initialize the instance fields of an object. So you ever wonder what to put in my constructor? It just has to take care of, in some way, all of your instance fields. So for our bank account, it's always going to be the same name. So in my class bank account, I have a constructor called public bank account. No parameters. And so the user is not going to give me anything. So I have to come up with what do I want to do. Now the bank account only has one instance field, that is balance. And my default, I'm going to set it to 0. I have an overloaded constructor, so I have another constructor, so public bank account, same header, except I'm going to have some initial balance as a parameter, and then my balance instance field should equal that initial balance. So to see how these constructors work, let's trace the statement bank account Harry's checking equals new bank account 1000. Okay. So first it's going to create a new one. So if I had bank account Harry's checking, I ran out of room. Alright, so class name, object reference or object variable, my object name, new keyword, that means I'm calling a constructor. I'm going to construct a new object, you have to use the keyword, and then the constructor header that I'm going to use. So this constructor header is going to be my one with a parameter in it because I've provided a parameter in my constructor. So first it's going to create a new object of type bank account. It's going to call the second constructor Set the parameter variable initial balance to 1000. So this number goes in here. This is a parameter. It's only alive as long as the method is. Set the balance instance field to my initial balance. Do that part right there. Return the object reference. That is my memory location. Where do I find all of this information? Gets stored in Harry's checking variable, and that stores the object reference in the Harry's checking variable. So let's look at the methods. 3 methods of a bank account class. We've got, deposit, withdraw, and get balance. First two are mutators, second one is an accessor. So deposit should just add money to my account. It's going to be public, void return type because I'm not getting anything back, and then the name, and then the parameter. How much do you want to deposit? Then I need to set up my account. Now I'm going to shorthand it. The computer is smart enough to know it actually goes backwards. It starts right to left. It takes my balance, adds my amount parameter to it, adds it to my balance, and then resets my balance to my new number. Withdraw looks the same, except it's a subtraction amount. And then public double get balance. Any return or access method has to tell the computer the type of information you're giving me back. I'm going to return my current balance. Okay. Since balance is a double, my return type for the get balance method also has to be a double. All right, so page 97, 98, that is the bank account class. So if I were to look at it real quick, not sure why rectangle's over there. All right, so let's open the editor. Let's look at a bank account. So again, author, who you are, the version. In this case, the tutorial, but should be like, P 3.1, 3.2, and then the date. Public class bank account. My instance fields, first thing, right? Always put those in first so you know what you're working for. Private double balance. Java doc. Right? If I come up here to the documentation, my Java docs are nice and in there. Public class bank account. Bank account has a balance that can be changed by deposits and withdrawals. There's my author and version. Then your constructor summary. Right? And I know it's smart. Bank account, no parameters. Constructs a bank account with 0 balance. That's the part you have to provide. Bank account, double initial balance. Constructs a bank account with a given balance. And then these even work. It even does the HTML for you. All right, so that's JavaDoc. Go back to source code. So my 2 overloaded constructors. Then deposit, withdraw, and get balance. Add interest is for homework number 3.2. I put that in here. And we went over all these in class, but balance equals balance minus amount from a deposit. So again, public void deposit double amount. Void because I'm not returning. Name parameter. I mutate my balance. Get balance. It's a double type. Return the balance. And then public void add interest with double a rate. So if it's like 10, I got to divide it by 100 here. Okay, to get my actual decimal value, multiply that by my current balance. Store that as a double of interest, and then I just add the interest amount to my current balance. So self-check. Question number 9, page 98. The rectangle class has 4 instance fields, x, y, width, and height. Give a possible implementation of the getWidth method. Well, it's probably just going to be something like public int, because it's an integer type, getWidth with no parameters, and I'm just going to return the width. Give a number 10, give a possible implementation of the translate method of the rectangle class. All right, it's going to be a void. I'm not returning anything. I have a x and y coordinate, and remember, all it does is it adds to my x and y value. So I just take my current x value and then add my x parameter. Then I take my current y value and add my y parameter. All right. Number 3.6, unit testing. Okay, you can't execute a bank account class file once you've made it. It doesn't have a main method, which is where the computer starts. Now, BlueJ, again, is nice in that I can right-click and make a new bank account. Either way, let's go with a double initial balance. Constructs a bank account. There's my lovely Java.comments. comments. Name of the instance field, and then I have to give it that parameter. All right. Now I have a bank account, and I can come over here, right-click, see all the methods it knows how to do. And if I inspect it up here, then all of a sudden I can watch these things change. So let's go and deposit $500 more. Okay. And now it's changed. Okay. So I can in BlueJ make an object of a class without having a tester, but a tester verifies that a class works correctly. So to test a class, you want to use an environment that can do that like BlueJ, or you're going to write a tester class. Tester class is going to construct more than one or more objects of the class, invoke one or more methods. Really should run all the methods, print out the results by the computer doing the work, and then print the expected results where you do the work by hand. Okay, so bank account tester says public static void main bank account Harry's checking equals new bank account, deposit $2,000, withdraw 500, and then get the balance and print the expected result. Now we would do the math ourselves. So we would say if I deposited 2,000 and I subtracted 500, well, obviously that should leave me with $1,500. So you're going to have that last line. And that way you can check if your get balance command actually works right. And most likely it won't be the get balance command that's wrong. It'll be the math that's changing your balance. Because get balance shouldn't change anything, it just reports what your current balance is. So if this came out to be 2,500, your withdraw method, instead of subtracting 500, was adding the 500 in.